In this video, I'm going to show you how to go over So what this stands for is C will be our carbons, H will be our hydrogens, and O will be our oxygens. So this tells us the order of how to actually balance our reaction. So let's take a look at our first example. Okay, so what we're doing here is we have our hydrocarbon, CH4 or methane, and we are adding oxygen to it. So whenever you see a combination of this, we know it's going to be combustion. We're going to assume for these ones it is complete combustion. So our products will always be CO2 and water. Now, using our chocolate rule, we're going to go ahead and balance our carbons first. So right now I'm looking at my left and my right. And so to keep track of them, I'm going to draw a little line here and list my carbon, my hydrogens, and my oxygens. So I'm looking at my carbons. Okay, I've got one carbon on the left here, one on the right. So far, so good. Now I'm going to look at my hydrogens. Well, I have 4 on the left here and only 2 on the right. So of course that's not balanced. So to balance it, I'm gonna add a 2 in front of there. So that's our coefficient. So now we can say we have 2 waters with each water containing 2 hydrogens. So now we have it completely balanced on both sides. So we've got 4. Our last thing to look at is our oxygens. So my oxygen on the left is 2, but on my right, I have 2 from the carbon dioxide and 1 from the water. So I actually have 3 there. And then we also added our coefficient of 2. So I'm gonna have to count for that. So my oxygen on my right is 4, which now means I need 4 on my left. So I know I have 2 there. That means I'm gonna need to pop a 2 on there. And that will give us 4 oxygens. And that is my reaction completely balanced. All right, let's try another example. Okay, so in my second example, I have another hydrocarbon, so C3H8 and O2. So again, we're gonna assume complete combustion. So we're gonna get CO2 produced with some water. So that's the easy part about this, is the products are always gonna be the same. Now let's go back to our chocolate rule. We have to balance our carbons first, hydrogen second, and then our oxygens. So again, I like to write out a little line here. All right, so if I look at my carbons on the left, I have 3 of them. And on my right, I only have 1, so we need to add a coefficient of 3 to this. Then the next thing I need to balance is my hydrogens. Well, on the left, I have 8, and on the right, I have 2. So I'm going to want to add a 4 in front of this, right? Because 4 times 2 is 8. So now my carbons and my hydrogens are completely balanced. So last, I have to look at the oxygen. Well, by adding that coefficient of 4 to the water, that means I have 4 oxygens on the left, plus the 6 from the carbon dioxide. So that's going to leave me with 10. While I've got O2 on the left. So I'm going to need to take my 10, divide it by 2. You can see where all that math is coming to play. And that's going to leave us with 5 O2, balancing this out at 10 oxygens on either side. Okay, so for the third example, I've written out the hydrocarbon. I've added the oxygen. Pause the video and see if you can come up with the products and the balanced chemical equation. Remember our chocolate rule. You want to balance the carbons first, hydrogen second, and then the oxygens. Okay, so just as always, when we do this, our products are going to be carbon dioxide and water. Okay, so if we're balancing it, we're going to go ahead and look at our carbons first. So on the left, I have 5 carbons here, which means I'm going to need to add a coefficient of 5 to my carbon dioxide. Now let's go ahead and look at our hydrogens. So on the left, I have 12 hydrogens. On the right, I just have 2, so I'm going to need to add a 6 to that. Now both of them will be 12. And finally, we have to look at our oxygens. So on the left, I just have 2, but on the right, I'm gonna have to do a little bit of addition here and multiplying. So altogether on this one, I have 16 oxygens, which means I'm going to need to add an 8 in front of this one and an 8 there. Okay, I hope that helped. In the description, there is a worksheet so you can practice what you've learned. And one of the things I wanted to mention is I kept talking about complete combustion. So that's when you get the CO2 in the water. In incomplete combustion, what happens is you don't have enough oxygen present for the combustion. So what happens is you end up producing carbon monoxide and then carbon on its own and still a little bit of water vapor. So I hope that helped. Good luck with balancing equations, and I'll see you guys in the next one.